The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everyone, and welcome to today's webinar discussing development of packaging and MGC's innovative packaging technologies for safety and sustainability, organized by MENA in partnership with Mitsubishi Gas Chemical Group. My name is Maggie Fays. I am the sales manager of MENA. And on behalf of the team, I'm honored to be the moderator of today's webinar. In today's webinar, we will look at how MX Nylon, an innovative barrier packaging material made by MGC, is able to further extend the shelf life of various products and the values that MX Nylon can bring to brand owners, consumers, and societies. We will be joined by Mr. Ryan Tan, Senior Sales Officer at MGC, Mr. Albert Lim, Senior Sales Manager at MGC, and Mr. Takaroni Miyapi from MGC. We are starting off with answering one of the most pressing questions in today's packaging world, which is plastic packaging a problem or a solution? Followed by a brief introduction about what is MX Nylon and how it is used in F&B packaging. Then moving forward, sustainability. And then closing with questions and answers. I'd like to remind you that this webinar is designed to be interactive. So we encourage you to type all your questions into the text box located to the right of the presentation window. Or you can click the questions and answers icon at the bottom of your screen and type in your questions. Now, I'd like to hand over to Mr. Ryan Tan. Mr. Ryan, over to you.
Sorry. Thank you, Ms. Maggie, for the introduction. And thank you, Mr. Albert, for joining us, and also Mr. Miyabe from Japan, who is also joining us today. So as per what Ms. Maggie has informed and explained, today, Mitsubishi Gas Chemical is here to share with you our development on packaging and our innovative packaging technologies for safety and sustainability. Namely, the products that we'll be talking about will be polyamide resin, gas barrier polyamide resin, known as MX Nylon. I will be sharing a little bit more in the details at a later time, but just keep in mind of this gas barrier requirements, and like what Maggie has mentioned, we'll be covering a few topics such as whether plastics is really a solution or a problem as what the world has perceived. So with this, I will just go straight into the introduction of this webinar, and we will start. Okay. So first, I will introduce Mitsubishi Gas Chemical. As the Mitsubishi name suggests, we are a Japanese company headquartered in Tokyo. We are established in the early 19th, and till date, we have multiple plants globally. The companies develop business in a wide range of products, and these products are split into two business sectors. Specialty chemical business sector takes care of specialty chemicals such as optical materials, hydrogen peroxide for aseptic cleaning systems for the beverage industry, and oxygen absorbers for the food industries. The team today comes from High Performance Product Division in the basic chemical business sector. In this business division, we have products such as MX Nylon, Maxif, and Altestas, which are solutions that are suitable for food industries. However, we will be focusing on MX Nylon today. Our corporate mission is understanding the needs of the time and contributing to sustainable growth of society, pursuing the limitless changes for new technologies, applying the power of chemicals. We have been providing, and we are still providing, a variety of solutions today. So what are we going to be talking on today? So the topics for today will be, number one, a brief history of packaging innovation. What are some of the challenges that COVID-19 brings about? Number three, the plastic packaging, is it a friend or a foe? And number four, can we truly be plastic packaging free, like what the world has been portraying? And finally, we will share how MX Nylon can help in reducing the usage of plastics. So let's go into the first item, a brief history of plastic innovation. Plastic innovation, as we know, have all been coming into different materials in the packaging industries. I will quote a Greek philosopher, Heraclitus: "Change is the only constant in life." Likewise, the need for packaging has been constantly evolving and changing to suit the need of the current people's lifestyle. But does anybody knows which packaging comes first and how they came about? Next, I'll be spending some time to talk about all these different materials. The first type of packaging actually came in the form of natural materials such as the leaves, animal skins and organs, nuts and galls. These were used previously to transport food and water. Next, I believe most of the people who have joined us today are from the same countries. They are the Egyptians. Next, the Egyptians developed glass, and glass has been used to make water pots and mugs. And then the Phoenician invented blowpipes for glasses. And then in the 2200 BC, the Chinese with treated mulberry bugs to transport food, and this was known as the first packaging, flexible packaging. Then we go to the 5th century, the medieval period. One of the most common material that we have seen, the most common kind of packaging, wooden barrels and boxes, which until today are still sometimes being used to store alcohol and other foods. Other packaging materials such as linen and wool rags were used to wrap beans, flour, meat, and salted fish. Paper making techniques were only developed later and were used for packaging items such as medicines and tea parcels. And after which, in the 14th century, the usage of tin food started. In the 1970s, a French found that food can be sealed in tin containers and heat sterilized, making them able to store the food for a longer period of time, which is what our General Napoleon has actually requested for, to preserve the army food. And then in the 1980s, sealed tins was patented for food instead of glass, and subsequently carton boxes or cardboard boxes were developed in England. In the 1800s, soft metal tubes were developed for paint. Corrugated paperboard replaced wooden boxes. Just one question: how many people have actually carried wooden cartons before? Are they heavy? Would it be hard to imagine why corrugated carton boxes replaced all these wooden crates now? It's not too difficult, isn't it? Then the first plastic came along. Bakelite was developed, Bakelite was developed in 1907. 1 year later, cellophane, the same material that we use to make our cellophane tapes, was developed, and this became the foundation for plastic packaging. And in the 1910s, aluminum foil was launched in the market. By the 1940s, as we come closer and closer to our current age, plastic bottles started coming out into the industries. The first plastic bottle was launched in 1946, and this was made from PVC for deodorant spray bottles. Subsequently, paperboard-based packaging to store within refrigeration was invented, and aluminum foil cans came out in 1950s, and subsequently, aluminum can and pull ring cans was introduced in 1963. Then, in the 1968, the first biaxial-oriented polyamide, in short known as BOPA, or some people will know as BOPA films, was developed. And in the first plastic bottles to start to replace glass bottle was found in 1973. Next, in 1977, oxygen absorbers known as H-less that was developed by us, Mitsubishi Gas Chemical, was launched for packaging. And then in the 1970s, advantages of plastics started to gain popularity, such as the versatility of plastics. The transparency, while not breaking easily, made it a popular material in replacement of other materials. With this knowledge, plastic packaging started to undergo transformation, where the understanding of barriers started to come up and smart packaging started to develop. With the increase of barrier properties of packaging, helps to extend the shelf life and the food products. The followings are being achieved: reduction in food waste and food loss, enabling the products to be sold to a further location, has been enabled by the different companies. In 1984, gas barrier polyamide resin MX Nylon was commercialized by MGC, Mitsubishi Gas Chemical, and we further supported the industry in the 1980s to develop barrier BOPA film and also barrier PET bottles. In the 2000s, these applications have started to be widely used as a functional packaging for food and beverages. Smart plastic packaging can help to achieve longer shelf life and for food and beverage, and also makes it easier for the consumer to visually notice the quality of the food and beverage. With this, I have covered the history of packaging. Next, one of the biggest problems in COVID-19 are the challenges that this virus has bring along. Like, for example, the things that everybody loves so much, to travel. Traveling has been affected, but the bigger problem now is plastic packaging a friend or a foe? In this COVID pandemic, we have all seen disruptions to supply chain globally. Closures of food establishments during lockdown and empty shelves in convenience shops as a result of food hoarding. This has caused further stress on supply chain for food product, where the export of fruit is restricted because countries are considering their citizens as priority. One example that I have actually bought before, grapes from Egypt. As a result, the requirements for longer shelf life has been magnified. Food packaging has become a solution or have been considered a fail-safe, where consumers are faced with the worry of contamination from COVID-19 virus. However, plastic packaging has also helped to solve food waste and food loss problem. Furthermore, with more people working from home, the sales of ready-to-cook and ready-to-eat food has gone up tremendously. COVID-19 has caused a big problem globally, which everybody would agree. Globally, daily life has been affected. In our life, most, if not all, the things around us have been packaged. There are food packaging such as PET bottles, or flexible bags, or trays, or even personal care bottles and industrial chemicals bottles such as HDPE bottles for soap, shampoo, or pesticides. COVID-19 has also brought about the requirements and enhance the understanding and the need for the country to ensure food security and availability for its citizens. Furthermore, due to this COVID-19 virus, consumers started to worry about catching the virus from touching the food. However, food packaging helps to prevent the virus from getting into contact with the food, resulting in an increase in food safety. During this period of time, we have also seen shops closing down as a result of poor sales. We have also seen supermarket and hypermarket sales exploded. And during this period of time, the shelf life of food is important because supply chains have been affected, where the people who are buying the food are thus keeping them longer, and the requirements for longer shelf life due to requirements to keep the food longer and longer time for delivery. How do most companies increase the shelf life? Generally, everybody's mentality is it is just to increase the amount of preservative being used. However, another way to increase the shelf life of food is to improve the food packaging. And here we will be discussing on the barrier properties of each materials. With the improvement in food packaging, it is possible to enable high-value food while retaining its original flavor. Our solution is to improve the food packaging through the use of MX Nylon, which I will explain in details. One of the biggest issue or misconception in our current era is plastic is bad. I believe the trigger for this is a video which I'm sure most people would have seen. Yes, I'm talking about the video where a straw, a drinking straw, is being pulled out of a turtle nose. Even a cartoon animation globally has shown penguin with plastic rings around their neck acting as their crown. Surely these plastic products must be bad since they are portraying a very bad image. However, have everybody stopped to think, why were these products developed? All these products were developed with the view of the ease of humans' mentality and the ease of our lifestyle. With also considerations for safety and hygiene, all these products were developed. In one of the documentary I have watched recently, I quote a conversation between the host and the guest. Packaging plays a very important role in preserving the quality and freshness of the food from farm to table. So, if you were to look at vegetables that were sold loose versus vegetables that were pre-packed, the shelf life extends from 4 days all the way up to 16 days. That's a whopping 2 weeks. While plastics can be a problem, the bigger problem is actually plastic waste. Without plastics today, we will have significant increase in product loss and waste. Imagine suddenly having the urge for certain food that is grown halfway across the globe. Without good packaging, these food cravings can never be brought back, or when we are on a holiday and we would like to bring back some food as souvenir. Without proper packaging, these souvenirs would never be able to be brought back to our home to be shared with our loved ones. Next, one of the biggest things that we have heard, plastic is the biggest cause of global warming because they come from the mining of petroleum. However, let's take a look at some of the greenhouse gas emission data that we found from a scientific online publication called Our World in Data. They mainly focus on large global problems. In this chart, greenhouse gas emissions are color-coded. And the green stands for land use, brown stands for farming, gray stands for packaging. As you can see over here, the bulk of the greenhouse gas emissions comes from farming in brown as compared to packaging in gray, as you can see through the different materials. Of course, under packaging, we have other materials such as glass and aluminium, which I have explained at an earlier time. But all these materials will portray a different amount of greenhouse gas. But if you look at it from a whole picture, these values are still much lower as compared to other processes. Furthermore, all this packaging helps to increase the shelf life and the value and even the safety of the products, making it more environmentally friendly, and the effort that the farmers have actually put in to grow the food that we need. have not gone to waste. Now, I will proceed to share our innovative barrier materials by Mitsubishi Gas Chemical, MX Nylon. Throughout this presentation, you would have probably heard me repeating MX Nylon, MX Nylon, MX Nylon multiple times. But what essentially is MX Nylon? MX Nylon, it is an innovative barrier packaging material made by us, MGC, which offer excellent gas barrier properties and has compatible processing range with various materials. It also provides high tensile, flexural strength, which is important for flexible standing pouches. Other chemicals such as excellent thermal stability and chemical resistance properties enable special packaging materials, which I will touch on in a while. In packaging materials, the most commonly used plastics are polyethylene and polypropylene. However, polyethylene or PE and polypropylene or PP have very poor oxygen barrier properties. Thus, they would not be able to extend shelf life significantly. In this slide, we looked at oxygen permeability of other more commonly used materials such as PET, PET, Nylon 6, and MX Nylon. Oxygen permeability means how much oxygen will pass through the packaging and is usually affected by the plastic type, the thickness of the film, and the size of the film. You will notice that oriented poly PET film has about 7 cc of oxygen coming in through the packaging as compared to oriented nylon 6, or more commonly known as OPA, has an oxygen permeability of about 0.7 cc per meter square per day. And if you compare further to MX Nylon, the oxygen permeability is about 0.06 cc per meter square per day. All these numbers sounds interesting and the numbers seems to get smaller. But the important thing is, what does all this value means? Assuming that all the film thickness are the same and an oxygen concentration of 10 cc is required for the food to start to turn bad. It usually takes about 2 days, mathematically speaking, for the food to start to turn bad for food packed in PET. But when packed in OPA, it will take about 10 days, and when packed in MX Nylon packaging, it will take more than 3 months. All these, however, are just estimates, and the customer will need to perform their tests because different products have different formulations and are prepared differently. So the requirements are different. Earlier in my presentation, I mentioned that MX Nylon has a wide processing range, and you can see over here, it is suitable with various materials and is able to process with other materials such as PET, polyamide 6 or 6,6, and also PE and PP. MX Nylon has been used in both rigid and flexible packaging globally. Some of the current application of MX Nylon can be found in PET bottles, films, and even PP thermoform trays. With the rise of retort sterilization, packaging are required to endure higher temperature during processing, and MX Nylon, which has excellent thermal stability, is able to retain its barrier properties even after undergoing retort process. When producing PET bottles, MX Nylon has been used globally to improve the barrier properties of bottles by preventing oxygen from entering or carbon dioxide from exiting. The use of MX Nylon can be applied to 2 different technologies. Number 1, blending MX Nylon with PET bottles, or 2, using multi-layer PET bottles. In terms of shelf life improvement of gas volume loss, the end user is able to achieve 1.8 times more shelf life as compared to its original shelf life, and when using blend bottles, and 2.4 times more when 2.4 times as compared to its original shelf life in the multi-layer bottles. There is a minimum tool investment cost when using blend, but the multi-layer technology enabled very clear PET bottles that is similar to a normal PET bottles. All these materials that we are suggesting, that we have been providing, such as MX Nylons, are in compliance to design guidelines for bottle-to-bottle recyclings in Japan, Europe, and US. One thing that a lot of drinks that we need to look at is teas that a lot of people drink. The examples here is a green tea. Green tea contains polyphenol, which is sensitive to oxidation. When tea is brewed, polyphenol is released. When this polyphenols is exposed to oxygen, their colors darken. Taste also change, but color is more obvious because as a consumer, we make decisions based on what we see first before we taste. It is a common idea to lightweight bottles, as it is a way to be more sustainable. However, when chasing after lightweighting bottles, product shelf life can decrease as a result of lightweighting. And why is this? This is because the barrier properties of these bottles will drop. However, by using MX Nylon, we are able to lightweight the bottle while keeping its original barrier properties, and thereby allowing you as a consumer or customer or a brand owner to retain its original shelf life. One of the concerns from brand owner with the rise of Rpad, the usage of Rpad, is acetylene aldehyde, also commonly known as AA, and formaldehyde, also known as FA. These products can leach out of all these different materials and be found in the bottle, in the beverage. Most people will question, why is AA and FA a concern for beverage? This is because AA and FA can cause a change in taste. By using small dosage of up to 0.5% of MX Nylon, we would be able to achieve a 23% reduction in the AA content, therefore keeping the taste of the beverage. Okay, all right, enough with the beverage. Now let's go to something more interesting, food. As a consumer, we make our purchase decision based on the appearance of the food. Personally, I believe we always consider the smell of the food first, because considering the appearance of food, we need to see it. But when we are standing afar, the first thing we will do is we will smell the food. However, when the food is packed, there is no way that we can smell the food. Thus, we can only choose based on the appearance that before we buy them. In this slide, we can see the original color of tuna or fish floss. The color is very nice. However, once we cooked the product again, colors will darken. And this is due to the oxidation of the food. When comparing the floss packed in MX Nylon film against other barrier materials, the color of tuna floss is nicer when it is packed in MX Nylon film. When this happens, consumer will be more willing to purchase your products because there are less competitors who can achieve the same color, and therefore making the end user able to achieve a premium product. All these are based on transparent packaging. Next, let's take a look at fruits. Here is an image of mango. In the mango, you will notice that a mango, before it has gone through pasteurization process of 85 degrees, the color is very bright. But after pasteurization, the colors of the mango that is packed in other barrier materials has dulled significantly. Whereas for MX Nylon, the color retained its brightness. So one question that most people will ask is, why? MX Nylon do not undergo thermal degradation and is more thermal stability and has higher thermal stability. So when you look at fruits, for example, we would tend to look at whiter and fresher colors. And all this is due to oxidation. So when you try to cook apple, for example, the flesh of the color of the apple will change from white to pale yellow to dark yellow or brown. Likewise, in the case of mango. By using MX Nylon in their barrier tray, there are less oxygen entering the packaging, which cause oxidation of the vitamin C's in the mango, thus keeping the color bright. This allows the product to be marketed as a higher value product without the use of additional colorings or preservatives. So all these discussions about food packaging, some customers or some people would already have started to ask, what about personal care or chemical packaging? We are pleased to inform that MX Nylon can be used in those applications as well. And one of the applications is bleach, and even in industrial pesticides where the requirements are slightly different. This is an example that we have helped one of our customer move. So the customer was using HDPE bottles to pack their bleach However, and they would like to switch over to PET bottles. However, they found that when they use monolayer PET bottles, the PET bottles will crack and bleach will start to leak out. Another common name for bleach is sodium hypochlorite. However, by adding 5% MX Nylon into the blending of PET, we were able to remove this cracking issue, and the shelf life of the products can be extended up to 12 months without any damage to the bottles, thereby enabling excellent chemical resistance. Other applications such as whiteboard ink marker and automotive paint correction paint bottles are examples that MX Nylon has been used. MX Nylon can be used to replace barracks where solvents are common, to replace barracks-made material bottles. All these applications, such as what I've mentioned, whiteboard marker ink and automotive paint correction bottles, are generally high in solvent content. And MX Nylon, with its barrier properties, is able to prevent solvent loss. And at the same time, MX Nylon is also chemically inert when exposed to all these solvents such as toluene and xylene, and even for ethyl acetate. Other applications and other customers that have considered, because MX Nylon has high tensile modulus, it is also used to increase the stiffness of the bottles. Having a stiffer bottles helps the customer to prevent paneling issues found in some of the HDPE multi-layer extrusion blown bottles. Like I've mentioned earlier, MX Nylon has good barrier properties, but what other barrier properties does it have? One example that we have found is it has a good odor barrier as compared to other barrier films. One of the common aromas that is being used globally, limonene, which is the fragrance of orange, and vanillin, which is the extract of vanilla beans. And these are all very strong smells. MX Nylon is able to retain the shelf life of the products that enable it to be longer than 2 weeks. All this being said, now with the rise of food scare, people will start to ask, is MX Nylon food contact safe? Has it been approved? We are pleased to inform that MX Nylon has been approved in various bodies globally, such as Japan, US, Europe, and even in China. Now, we will talk about a very sensitive topic, sustainability. Why do I say sensitive? Because different people have different opinions of things, and some people have very strong belief of certain sustainability considerations. Nonetheless, this is our sustainability roadmap, and our target is to achieve net zero greenhouse gas emission in manufacturing and achieving a renewable raw material. The final goal for us is to support our customer and move towards a sustainable society. Like I mentioned earlier during my presentation, reducing food loss and food waste ensure that the energy and effort used in the cultivation of food products for our consumptions are not wasted. To move ahead of the current sustainability discussions, Mitsubishi Gas Chemical has also joined R+ Japan Co. Limited, which is facilitating the recycling of used plastic for a more sustainable society. In this recycling consortium, you will find various companies ranging from chemicals companies such as ourselves, to film packaging manufacturers and ink manufacturers, and you can also find brand owners in this consortium. In most parts of the world, plastic waste are collected, consolidated, and incinerated in a waste-to-energy plant. However, R+ Japan is working with NLO-Tech Inc. to develop a chemical recycling process where plastic products are converted and made into new plastic materials. With the omission of a single step, this new technology is expected to reduce carbon dioxide emission and the amount of energy required, thus making it more environmentally friendly. There have been some good results in NLO-Tech, and they are planning to commercialize this technology by 2027 to help to solve global challenges associated with plastic waste. Next, the other arm of sustainability. Apart from recycling, some people are discussing on the usage of bio-based material. We are pleased to introduce our very own bio-based polyamide resin known as Lexter. Our feedstock comes from non-food source. This is very important because using food source products or feedstock will affect the supplyability of food. And we know that the supplyability of food is important for every citizens and people on this planet. Therefore, our product food source, our polyamide resin feedstock does not come from food source. This product also provides excellent oxygen barrier properties and chemical resistance. By using Lexter, it is possible to increase the biomass percentage in the film, thereby helping the customer take a mass balance approach as well. As you can see over here, by using 100% MX Nylon, you have 0% of biomass, whereas by using 10% of Lexter, your biomass degree increased to 3.7%. In conclusion, MX Nylon can be used to enhance barrier properties of your packaging, thereby increasing the shelf life of your product and reducing food loss. It is important that we consider the value of packaging and what it can bring versus the environmental impact when not using packaging. I repeat, we should not solve the plastic problem by causing another problem, such as food shortage. We have enough people dying of starvation. If you require any assistance in packaging, regardless whether it is for food, chemical, or personal care, feel free to get in touch with us, and we will be happy to share our experience and propose solutions for the problems that you are facing. With this, I have come to the end of my presentation. Our contact details are as shown. You can scan the big QR code on the left to access our MX Nylon website, or the smaller QR code on the right, bottom right, to connect you to us via email. We will now proceed to the Q&A session, and I will hand the time over to Mr. Albert.
Thank you, Ryan. And thank you, the participants in this webinar. I hope you will still stay with us, because typically for the webinar, I think the Q&A typically probably brings the most rewards for the participants. I'm also very grateful for the huge number of questions that have been sent to us. It was also very challenging for us to actually prepare for the MENA webinar, because we were told to share a wide range of information from the basics to certain high level of technologies as well as applications. So without further ado, I will go to the questions, and through these questions, I hope you will be able to learn more of our products from MGC, especially MX Nylon, as well as the other products that we have. I want to highlight again that actually from MGC, the team that is supporting this webinar today mainly is involved in MX Nylon, but at the same time, we are also involved in similar products or related products in packaging. Let me go on to the questions. So first questions that we had, and maybe before the questions, I want to highlight something. So the information that we shared today with you from MX Nylon is actually part of a new technology of packaging. And this technology is actually called modified atmospheric packaging. So being in the Middle East or MENA region, so typically a lot of people are very familiar with olefins, PEs and PPs. And those materials are very good for moisture barrier. However, in the world and with the advent of time, actually we found that aging, one of the key radicals, right, is actually oxygen. Oxygen actually causes aging, not just of people, but of food. And also pharmaceutical ingredients. And one of the key reasons why barrier materials, passive barrier materials, or simple word is blocking, right? Blocking materials, blocking oxygen from coming in, is actually gaining a very big usage, is especially for the protection of aging via oxidation. And also to a certain extent, certain man-made drinks like carbonated soft drinks, etc., of preventing these gases from going out. It's either preventing the oxygen from coming in or preventing the carbon dioxide from going out. Right? So these are what we call passive solutions. And actually in this field of packaging, there's more advanced solutions, and those are called active packaging. So it incorporates blocking, which is your passive material, to block either the moisture incursion or the oxygen incursion or both, as well as to absorb the oxygen or the moisture that's already inside the sealed package. And I would like to add, as what Ryan mentioned in the starting part of the PowerPoint, actually MGC is the inventor, the innovator for ageless oxygen absorbers. And ageless oxygen absorbers, I want to highlight something even before we go on. So actually we are the company that supports the preservation of Egypt's artifacts in the British Museum. We are only talking about about MX Nylon today, but if you went to watch the National Geographic shows, you will see an integrated system whereby there's packaging film and there's also a sachet, multiple gas absorption sachet. Those products are actually made by MGC. We take care of what's coming in, and we take care of what's already inside, so that the gas environment, the packaging environment is able to actually extend the shelf life of artifacts easily by 5 to 10 years. And of course, there are other non-civilian applications for those technologies. But today, let's just focus on MX Nylon, and we will go into your questions. All right, a lot of questions, so I will pick and choose. If we cannot answer all today, we will take time to get back to you via your questions and your email contacts, and we start the discussions then. First question, what is the hazard of cans, PET bottles, and glass bottles? So this is a very complicated question. So for cans and glass, the main issue now, especially for the processing of materials, it is high temperature. So when you are trying to melt or smelt silicon oxide, or trying to smelt different formulations of steel or aluminum, what happens is actually those temperatures required to melt or smelt them, and then to form them and even to recycle them, is very high, which means the carbon footprint from those processes are so high. let me give you an example. Glass typically 6,000 to 7,000 degrees to be able to melt them, right? For steel, you're talking about maybe 1,600 degrees. For aluminum, you're talking about 600 degrees and more, right? Steel 1,004 to 1,006, aluminum 600, glass 6,000 to 7,000 degrees. How much of fossil fuels do you need to burn, right? High calorie fossil fuel to be able to hit those temperatures, right? So when you're using polymers, the temperatures typically range from 100 plus to 200 plus to at most maybe 300 degrees. And then the carbon footprint, the what we call the greenhouse gases emission from the manufacturing of the plastics as well as the use of these plastics in the factory is much lower. And I think this is where, when you saw the chart that Ryan shared from our World in Data, which is a outfit in Oxford University, they are trying to tell you actually the manufacturing of food as well as the land preparation takes so much energy, and actually the packaging itself is maybe 3, at most maybe 7-8%. And if you're able to use high quality 3 to 7-8% of this, you're able to protect the food that have caused so much harm to the environment, right? The 90%, 92, 93%. So you're able to not waste all this food and not lose all this food. You're actually able to extend the shelf life of the food, able to sell it to further geographies. You're actually in one way providing food to a wider geography as well as to save the earth. Okay, so the main issue is energy consumption and the generated greenhouse gases when you're making glass and you're making steel or aluminum as compared to plastics. Okay. Second question, what are the equivalent products to MX Nylon? In the world itself, at the moment, MX Nylon is the only specialty nylon that can be made in conjunction with polypropylene or olefins as well as PET to make heat shock resistant barrier materials that still offer pinhole resistance. So it's hard to burst, it's hard to have holes. It gives you protection before and very shortly after the heat process. And at the same time, it's able to block the oxygen and CO2 from coming in or going out. All right. So this is a very unique product. It is only commercialized by MGC. Okay. And we have production sites in Japan and in US. There was a related question by a participant who says, can SMEs, small companies, actually use these technologies? And the answer is obviously yes. So if you're a beverage manufacturer or if you're a food manufacturer, you can actually work with converters who are able to make these bottles or containers. All you have to do if you're using PET is actually to blend. And I think Ryan mentioned the adoption of the technology for blending is actually very low cost. You have an existing injection molding machine, you just need a doser. And after that, you can just dose to a specific dosage content, and you will be able to achieve barrier properties and extend shelf life of your products. As Ryan mentioned, 5% dosage easily can achieve maybe 2.4 times your existing shelf life. For multi-layers, 5% into a blend can achieve 1.8 or 80% extension of your shelf life for your existing beverages. So there's a very easy adoption of these technologies in existing converters, people who make the films or people who make the bottles. All right, so it's easy to adopt. You just need to buy from people who are making the bottles and the films. Ask them to actually work with us. We will enable these technologies to be available in the MENA region for you. And in fact, these technologies are already adopted in MENA. You just don't know it. If you're buying expensive sparkling water from Europe, if you're buying carbonated drinks from certain US brands, actually the bottles are not what they seem. The metallic looking bottles are actually using our materials inside to achieve barrier as well as the metallic finish. The very high gassy sparkling is actually using our materials in the middle layer and lightweighting, right? In plastic bottle instead of glass, and they are giving you very high gas content when you're drinking the sparkling water, right? Next question, does nylon, well, I want to be specific, does MX Nylon help to meet sustainable packaging solutions? And I think Ryan shared, if you're able to use functional, high functional materials that can extend shelf life, that can, even increase the value of the food, you are in fact actually doing a part, your part, to actually enable sustainability, because you're not wasting food and you're not participating or adding to food loss, right? You're able to make food, able to make it last long, and able to sell to a wider geography, allowing more people to have access to your food. Okay, this is the key point. And I think Ryan also mentioned certain other technologies that we are doing, whereby we incorporate bio feedstock into the nylon structure of our material, so that we do something called mass balance, whereby we are able to actually be more friendly to the environment. We are not taking some fossil fuel. We are trying to reduce the amount of fossil fuel, the amount of carbon footprint that is being created by adopting some bio-based non-food source materials into our resin construct. All right. Our next question: what are the percentages of MX Nylon that's acceptable in a sustainable packaging? So this again is a very challenging answer, because we have many answers, because many regions have different ways of testing and acceptance. So we have the Americas or the North Americans who are at the moment looking at maybe 2.5%, right, in a certain structure. And you have Central America and even Europe looking at 5 to 6% for clear bottles. And you have actually Europe accepting 10%, right, for colored bottles, you know, those bottles that are meant to replace the beer bottles, the glass bottles, right, for liquor. So all this enables the lightweighting of the bottles, enables to have a very long shelf life against a normal olefin materials like polypropylene and polyethylene, as well as even PET. It strengthens PET, right? Next question. Give me a second. So there's a question about recycling technologies and what more detail about MX Nylon technology, barrier properties, and PET MX Nylon recycling. So as Ryan mentioned, we are already approved in US, in Japan, in Europe for a certain percentage of dosing. And please understand, we don't need to sell the whole bottle made of nylon. A low dosage, like what we mentioned, 2.5%, 5%, 7%, or 10%, will be able to extend shelf life by up to 80% or even 140%. So we are trying to make and get approved all those low dosages, and actually a lot of these regions are already approved. Next question. And this question is very interesting because there's a lot of know-how into it. It is probably from a food manufacturer, and the question was raised before the webinar and again now. So the question is, how does MX Nylon increase shelf life of chicken? And this is a very challenging problem, because when you have barrier material using the nylons, and I mentioned passive barrier, and you're able to reduce O2 incursion, the amount of oxygen coming in, and you will be able to slow down what we call the peroxide value, which is the aging of the oil, the natural oils. Natural animal oils or plant oils are light oils, and they oxidize, and you have this rancid issue, right? If you're able to slow down oxygen ingress, you're able to slow down the rancidity. However, there's another problem with chicken, and this is what we are talking about, fresh chicken. So the issues are with microbiology, and actually for certain microorganisms like Campylobacter, right? These are aerobic in nature. You are actually able, if you're able to retard or to absorb using some active solutions together with MX Nylon packaging, you will be able to slow down certain microbiological growths like Campylobacter, right? But however, like very challenging problems for chicken would be Salmonella, and Salmonella would be anaerobic / aerobic bacteria. So, and for people who are familiar with this problem, so when you cut down the oxygen, Salmonella, when there's oxygen-rich environment, it will absorb oxygen to grow, and the growth is very fast. But when there's no oxygen, it actually goes into the anaerobic state, and then the growth of the bacteria is slowed down. So when you have a barrier material, you're able to reduce the amount of oxygen. There's certain positive effects on reducing the growth, but it is not a perfect solution for Salmonella, but it does help in aerobic bacteria like Campylobacter. All right, and it's not mentioned here, but one of the key products in the Middle East or consumption is actually nuts. And actually for nuts, MGC is a very strong supplier of both the passive materials like MX Nylon into packaging materials, as well as active solutions like ageless, to help people who are doing sundry goods and nuts to be able to extend their shelf life. Next question. Typical sustainability issue. So what's the future of recycling? So as I mentioned before, or Brian mentioned before, I think the solution is not mechanical, simple recycling, because multiple heat exposure to polymers causes degradation and leaching. So taste change, chemicals, leaching, it is not healthy, right? So actually, for certain users, we actually work with them for not B2B, not bottle to bottle, but bottle to fiber. So actually, a lot of the packaging that you use, especially with beverages, goes into actually your textiles, right? And at the same time, as what Ryan mentioned in the PowerPoint, the future is actually chemical recycling and expedited fast-speed chemical recycling, where we break down all the plastics back into the feedstock. We don't use oil, right? We use the plastics and we break it down using solvents back into the feedstock so that we can make new plastics again. And this is what Ryan mentioned in the later part of his PowerPoint. Those are the newest technologies. Chemical recycling, using what has been used to make virgin, high quality products again, right? We don't have to suffer from low quality recycled materials. Next one, a lot of questions. Can your packaging products go for pouches for cereal, breakfast, etc.? And the answer is yes, and drinks. Of course, it is already being used. Multi-layer technologies in paper boards, in bottles, using our materials actually prevent pinhole. This is very important because there are alternative solutions, but they cannot provide pinhole resistance. With MX Nylon, we don't just coat, we actually one solid layer in the middle, and then we also prevent sharp products like chips is actually to make holes in the packaging, and this causes the gas incursion to occur, the oxygen incursion to occur, which will age your food. So specialty nylons, I think, is the way to go. Next question. Is there any way to replace nylon? Especially for flour products. The answer actually is a very interesting answer, because a lot of people will say the other thing better than nylon would be aluminum foil. But actually, in a lot of high value products, including even, I think in the MENA region, a lot of people are eating basmati rice. So actually, basmati rice manufacturers are now using actually aluminum bags, but in order to prevent the aluminum bags from tearing, because the rice grains are sharp, actually there's some structures whereby there is a nylon layer in the middle, right? And the nylon prevents the pinhole that I mentioned. It is a buffer barrier, it is a pinhole layer, and then the aluminum foils provide almost a perfect barrier for ingress of oxygen. And the question is why, right? In case people who are not familiar with sundry groups or range here, the key issue, of course, is insects, right? So if you didn't know, the key problem is actually oxygen. Oxygen makes insects eggs hatch. So if you are able to block oxygen ingress, then you're able to retard the eggs hatching, and within 2 weeks, if the eggs don't hatch, they die. And then you will remove, right? There's a high potential you're able to suppress the infestation issue due to the insects. Next question. What are some innovative packaging, and there's a term called styrofoam that was used, so foaming, that can withstand repeated freezing and thawing, that can be shipped worldwide. So let me tell you, actually MX Nylon is one of those products that are quite famous for having heat shock retainable barrier properties. So a lot of the other solutions are that coated, or they are made from some other lower end, not engineering polymer, but a commoditized material. So when they are exposed to heat, the polymers actually open up, right? The intramolecular spaces open up, and the gases go in and come out. And it takes a very long time, and some of them don't even actually revert back to the original structure. So you have your barrier gone for a very long time, and then your food ages. So MX Nylon's reversion of the barrier property is very quick. So this MX Nylon is actually a very good heat retortable and heat shock solution, all right? And in fact, actually, if you didn't know, most of the mobile equipment you're using is actually made from our material, all right? MX Nylon is just added with certain fillers and is made into the structures of your mobile equipment, okay? And also in automotive. So it's actually, in a short term, it's actually a steel replacement. But in this webinar, we are actually marketing it as a packaging material. It has both functions. It is a steel replacement. When reinforced, it is a very good barrier material. Right. Next, food grade products. Actually, if you are using MX Nylon for packaging, and MX Nylon enables a lot of the challenges of normal nylon, the nylon 6s, etc., to be overcome, because a lot of normal nylons, they tend to be actually very hazy. But for MX Nylon, we are able to stretch it into thin films, and these films are very transparent. So we are open to working with film extruders or converters to help them to be able to actually achieve thin film. And these thin films become cosmetically beautiful. At the same time, the barrier properties with films using our materials are much higher than the normal nylon 6s. And this again enables shelf life extension, and of course, again, contribute to sustainability. I'm going to speed up and a few other questions. What are the newest technologies? So as I mentioned, what we are doing here today, this technology has been around for a few decades. The improvements to this modified atmospheric packaging from passive, the next stage is actually active, whereby we block, and at the same time, we are able to add something into the resin or into the packaging environment, and we absorb the oxygen or the moisture that's inside. So you block using barrier materials and you absorb what's inside. The target for a lot of food manufacturers is to achieve something called total packaging oxygen equals to less than 0.1%. And this less than 0.1% can be achieved if you're using products from us like MX Nylon, together with additional products like additives into the MX Nylon, or a sachet of oxygen absorbers from us called ageless. And I say again, this solution is actually used by Egyptian artifacts. If it can preserve things for decades, I'm sure you understand it can be used for food. All right. Next, vacuum technologies. Here's the challenge. I want to go through just a few other questions before we end. And these are key questions. If you didn't know vacuum packaging, right? They will say they take out a lot of the vacuum, or the other way is they pump in flushing N2 gas. The truth is, it depends on what film you're using. Even if you're using aluminum foil, the foil doesn't seal aluminum to aluminum. Your sealers cannot hit those temperatures. The sealing layer is actually made of olefin, either PE or PP. And through this sealing layer is where all your gases come in and out, or moisture come in and out. So they are actually not perfect, right? So I think there are limitations. And even for transparent nylon bags, just simple nylon bags, or let's not talk about nylon bags. If you're using an olefin packaging material and you're doing vacuum, you're doing N2 flush, sadly, I think you're wasting your money, because the whole olefin, right, be it PP or PE, or even be it PET, it's an open window. You suck out the oxygen or the moisture, but after a while, they'll go through the plastics. The plastics don't perform a gas barrier property. They're just having a mechanical property to hold the food. It doesn't protect the food from the oxygen or the carbon dioxide or the moisture that's coming in. All right. Next, just a few other questions. And this is a very important question that we will want to share. We are not the leaders in it, but we want to share because we face similar problems. In emerging economies, there will be a lot of people coming in to promote biodegradable products. Coming from slightly more advanced economies, I would like to share. Actually, what happens is, I think the key material is PLA. This is a biomaterial that's put into any other polymer, and typically it can be the olefins in the Middle East. And the PLA, the polylactic acid, breaks down. It breaks the film down. And then what do you have? You think the plastics is gone, right? Oh, the material has actually degraded. But actually, it creates microplastics. So the films are broken down in very tiny bits of pieces, sometimes not even visible to the human eye. And if this waste is not actually managed properly, it goes in the sea. You're feeding the sea, the fishes, etc. Microplastics, which goes into the human food chain. So, and with discussions with a lot of the majors, the problem with biopolymers is also actually those biopolymers, they cause microplastics. And if you're looking at pure biopolymers, the key challenge has always been they cannot provide barrier properties. They just provide something to hold the fruit. They don't protect the fruit from aging, don't extend shelf life. They actually make the shelf life shorter, right? So what are you doing, right? So you need to be very careful about biodegradation. And if you read through the internet, actual biodegradation needs to be industrial scale. You cannot add something that breaks down into very strong plastics and wait for the plastics to break. It's the PLA that breaks, and the leftover, you cannot even catch it anymore, cannot even use it, right? Yeah, so you really have to be very careful when you're talking about biodegradation. You must be very technically experienced to be adopting that for your food. If not, you're causing more problem than helping the environment. So I just want to go through a little bit more, maybe one or two questions. And so there are some questions about equipment and machines, etc. So we do know machine suppliers, and we also, as a chemicals company, we are able to provide technical support. If you have any programs at all you want to try to use these barrier bottles, etc., contact us. We will hold your hand and walk you through the process with some suitable converters, and we have the equipment to test for you. So the question, can SMEs use it? Yes, you can. If we support you, we can test for you, we can measure for you, we can make sure that it's actually working before you adopt it. All right. And some other stuff that I want to highlight. So I just want to highlight MX Nylon is a passive barrier technology. It protects the food from O2 incursion, CO2 excursion, and maybe a certain proportion of moisture ingress. So if adopted with other newer technologies like active packaging solutions, where we are able to absorb gases within the packaging environment, then you have perfect solutions. And MGC has certain perfect solutions that we are not bringing today, but we will be more than willing to share with you if you contact us. So and up until this question, I think I've already exceeded the time. There are still a few questions that I've not answered, but rest assured, we will get back to you post-webinar. I just want to get some feedback from maybe Ryan and Miyabe-san. Is there anything that I have missed out, or maybe you want us to add in this webinar before we pass it back to Informa? Miyabe-san, daijoubu. Ryan, anything you want to add that I've missed out?
No, I just want to add on to one question that was actually mentioned just now, which we probably didn't explain clearly. So one of the question came in was regarding carbonated drinks. Packaging materials or products will contain formaldehyde. Will this apply to bottled water container? The thing is, I will just address this quickly, but I think the rest of the questions have been addressed by Mr. Albert. So it does not matter what you pack. It matters what you use to pack. So if you use Rpad, the chances of AA and FA reaching out into the drinks is high. The amount that is coming out will depend on the drinks, but normally for carbonated drinks are not as sensitive as 100% pure drinking water. So that could be a consideration for the person or the attendees of this webinar.
Thank you very much, Ryan. And with that, I want to give thanks to everyone who has joined us today. I also want to give thanks to Informa. So I'll pass the time back to Informa, Maggie, so that you can guide us to maybe conclude this webinar. Thank you so much.
Yes. Thank you all for this interesting and insightful presentation. I'm really impressed. Unfortunately, that's all the time we have for questions today. I'd like to thank our speaker, Mr. Ryan, and his colleagues, Mr. Albert Lim, Senior Manager at MGC, and Mr. Takanori Miyabe from MGC for being with us today. In order to better serve you in our future webinars, we would like to have your feedback. So within the next hour, you will receive a personalized follow-up email with a link survey to fill, as well as today's recorded session. Please feel free to invite your colleagues and peers who may have not been able to listen to the event today. On behalf of our guest speakers and myself, I'd like to thank you all for joining us today. And we are looking forward to seeing you again in our upcoming webinars and in our physical event in Cairo, which will be held in May 2022 from the 29th till the 31st of May. Have a great day.